Good morning, everyone. Let me catch my voice. I got morning voice. Okay. How's it going, everybody? My name is Aiman. Good to see you on here. I'm going to do my usual check first to make sure that I can hear and that you can hear. So I'm going to go over to Twitch on Facebook, Twitch and Facebook. So give me a minute just to check the stream. Okay. All right, so here we go. You guys can see what you're seeing. And let's check the volume works. Of course, I have headphones. All right, cool. Can hear myself on Facebook. I can also see your guys' comments, so just feel free to drop a line and I'll answer as soon as I can. I will also double check this is working on Twitch. Everyone have a good weekend. Hi, everybody. And of course, Twitch drops an ad for Reese's. All right. Hi, everybody. I'm going to connect my speaker also. So we can play some music in a minute. So you might hear a bit of double audio for a second. Yep, there it is. Perfect. All right, so online on Twitch and Facebook. Let's get this party started, everyone. So my name is Aiman, as already mentioned. I do the ZBrush stream every Monday mornings, 8 a.m. to 10 a.m. Pacific Standard Time. 3D printing in ZBrush, ideas to reality. If you want to learn more about my background, you can go to my site, which is aiman3d.com. See my reel. There's a whole bunch of 3D printing stuff because I'm a professional 3D artist in LA, and for the past 4 years or so, I've been doing a lot of different 3D printing projects. Large scale to small scale, stop motion animation, large scale sculpture, concept artwork, maquettes, toys, and recently my wife and I are launching our own blind box toy line, fungusaurs, little dinosaur mushroom hybrids. So that's what I try to do in this stream. I try to talk about bringing your own ideas to reality. And go over to here. If you go to pixelogic.com/ZBrushLIVE/presenters, you can see all the awesome presenters that are going to be doing streaming for y'all. And if you scroll down, you can find my past broadcasts and schedules. So if you go in there, you can see a little bit more artwork, and you can see all the past streams that I've done. So I tried to do a lot of work on my own IP, fungusaurs, and I've done like a costume, like a full 3D printed costume print for you guys. And last week I started a new one. I started a print for this guy back here, the Raise 3D N2 Plus, the largest printer in my inventory, 12-inch by 12-inch by 24-inch build volume. And I started this guy, which if you take a look in the stream, you can see me set up last week. So as a character I downloaded from HeroForge.com. That's the company I'm currently working at, Sky Castle Studios. It's an excellent customizer for miniature and tabletop gaming. And right now my job is to model and rig and pose assets for these fantasy characters, and it's really fun. So I downloaded this character, I got it in ZBrush, sculpted it up a little bit to make it look solid. That was the That was 2 weeks ago. And then last week, I believe should be this one, I took that character, showed you a little bit of a demoing. So I took that character, showed you how to fix it, showed you how to hollow it, and then how to set it up for FDM 3D printing using Idea Maker, which is Raise 3D's own software. And so if you want to see that video, you can find that on pixelogic.com/ZBrushLIVE. And I go through the whole process of setting up the print and kicking it off. And the plan was to have the print ready to show you guys today. It was about a 3-day print, and here it is. So it didn't come out at all, and this is something that is frustrating but happens quite often in 3D printing, even to experts. So I had one failure, one very small and quick failure, and I quickly realized what the problem was and why I didn't want to continue last week. And so I waited till this week to show you guys. So hold on one second, I'll be right back and show you what happened. Alright, so here's what happened. Put this away. Alright, so what happened last week was I had ordered some 3D printing filament in order to start my print, and I like this brand a lot. Hatchbox is one of my favorite filament brands, but unfortunately I ordered the ABS plastic. Usually with these kinds of prints I like to do PLA, and that's the two main kinds of 3D printing filaments for FDM, ABS and PLA. And I figured I'd take a second to talk about the differences, because if you don't understand the differences, this happens. Now this is the very, very start of a print. This is maybe like, I don't know, 1/100th of the filament used for a failure, which translates roughly to like, I don't know, 30 cents at most. So this is not like a big deal failure, but this is a common failure if you don't realize the difference between ABS and PLA. Now this printer, the Raise 3D N2 Plus, is more than capable of printing both ABS and PLA. It's actually designed in such a way that a lot of 3D printers aren't. You have a completely closed area. So you've got plexiglass up at the top and in the front and sides, and this is for temperature control. And temperature control is the main thing you have to realize and understand when you're printing in FDM, fused deposition modeling, any kind of printing that requires a spool of plastic. So with PLAs, which you can see right here, when you're printing on a machine like this, you can leave the entire top off. You can leave the door open. It doesn't matter really what the temperature is, because, I mean, it does matter what the temperature is, but the temperature doesn't need to be so constantly monitored and controlled and confined. PLA kind of smells a little sweet when it melts and gets added on. It's not as harmful to you, and the other thing is that because you don't have to worry so much about temperature, you get a bit more evenness and consistency in the print, just with one less thing, one less hassle. With ABS, on the other hand, you need to have the printer locked down. You need to have it closed if it's ideal. I'm just talking about ideal circumstances. You want the printer to be completely stable in temperature as much as possible, and the temperature has to be higher, maybe like 10 to 20 degrees higher than when printing in PLA. And the temperature in the printer has to be consistently higher. And the reason for this is when PLA melts when you apply the first layer, because that's what all the FDM printing right now is. It's like a hot glue gun that takes this spinning loop. It's like a hot glue gun end that melts it in the X and the Y axis and will lay down the first layer, and then start over again for the next layer, and then for the next layer, and then for the next layer. So it's basically 2D printing over and over and over and over. That's what 3D printing is right now using these kinds of machines. And what happens is PLA is very good at bonding to itself. And it has basically the temperature for the PLA material itself doesn't go down quickly. It stays hot. So the first layer that's been melted and placed down, it stays warm until the next one comes up, and then the next one comes up. They all stay warm and they build and fuse together very well. ABS, on the other hand, does not retain its warmth. Almost as soon as it's printed, the first layer, and this is just the scaffolding layer, as soon as it's printed, it's going to start cooling, and it cools, I believe, 3%, or I don't know the exact percentage, but it cools a lot faster than PLA does. And so what that does is that this bottom layer won't necessarily adhere to the build platform, and by the time you figure it out, it'll have already started the third layer, which may not adhere to the first or second layer. And so what happens is you get a giant blob like this. And in the case of my printer, the printer just grabbed this scaffolding and started moving it around the whole floor because it didn't adhere to the build platform. So in order to do it again, if I were to print using ABS again, I would start the print after waiting maybe half an hour for this printer, the whole area to heat up. And the whole printer itself would maintain a temperature higher than, if I were just printing in PLA. Now this is all good and well, and I would totally do this normally, and I would just start the print again right away last week, so I would have something to show you. But I just didn't want to deal with the hassle, and I'm not around all the time to monitor an ABS print, especially one that's going to be 16 inches tall. So what I did immediately was I returned the ABS, and then I ordered a new PLA material. Put this away. Unfortunately, the PLA hasn't arrived yet via Amazon. I think my payment was rejected because it was a new address I've just moved to and I didn't update my card. So I have to order a new PLA and then we'll print this. So I'll probably print this tomorrow or day after. So next time when you guys come to my stream on next Monday, I should have the full size print. So in any case, if you guys want to see how I went about setting this up in for FDM print, and then you want to see how I did it in ZBrush, check out my past 2 streams, and in my next week's stream, I'll show you the actual print. So last week I had a question which I wanted to address, which people were asking. This is the print, by the way, in SLA, done on the Form 2 right there, the Form 2 3D printer. And it's super small, it's a little mini. But this is the same character that we're printing, very tiny in SLA and very large in FDM. So I had a question last week, which was how do you go about setting up this print for SLA versus FDM? And I showed you FDM. This is what FDM looks like. It's printed straight up. I've added a few small supports for areas with overhangs, but majority of it is just all the detail, all the really good stuff comes on the FDM printer along the sides. So you don't want your print like this whenever possible. You want it vertical whenever possible. So because all the really good detail, it's going to come on the side. It's not going to come on the top. So if you got a really long flat print, a lot of the time the detail at the top won't look as good. And that's just because the X to Y resolution is very different in FDM printing. Y, which is the direction we're moving upwards towards the print head, it's going to always have less resolution if you just look top down at a printer like this than if you were printing vertically upwards, because the X and the Y, X and the Z axis have a lot more detail. And so this print is going to look really good in FDM, but I wanted to take a second to answer the last week's question and show you how I'd set up this exact same print for SLA on a Form 2. So you can get to see both sides of the 3D printing. SLA, of course, is resin-based 3D printing done with UV curing. So you've got a laser that hits the bottom of the printer, and that is what attaches it to the print head, to the build. So let me build plate. So let me pull that up right now. We're going to use a different software than last week. We're going to use Preform, which is Formlabs' own proprietary software for preparing these prints. Good to see a bunch of people on here on Twitch. How's it going, Sean Lake? Good to see you, man. Hi, Joanne. Yeah, this is exactly. Having to stay put and babysit a print for 3 days would suck. No, I don't want to confuse you guys. ABS has a lot of uses and a lot of advantages over PLA. The thing I don't like is having to sit here working for 3 days while ABS fumes fill my office. So that's one thing. Second thing is the temperature monitoring. But ABS has certain advantages over PLA. The primary advantage being that ABS, once it's cured at that higher temperature and it's all fused and working well, it's a stronger print. So ABS is better for prototyping than PLA is. Like if you say make a door handle or something that, a bookend, something that's going to take a lot of damage, I'd first try printing that in ABS rather than PLA. PLA, if you tend to leave it out in the sun, for example, for a couple of days here in LA, it will just start melting and deforming and warping. And ABS, once it's solidified, it's much more resistant to temperature changes. So depending upon the use, you use different types of filament, and you need to, understand and learn the settings. You can also, it's perfectly valid to have a preference, and I prefer PLA. Sean is saying I print in PLA and then mold and cast. And Legos are made for ABS. Yeah, that's true. Mass manufacturing often uses ABS plastic. However, they're trying to find a solution to switch off of it. Okay, so here's the SLA setup I'm going to start going into as I keep looking at your questions. For the SLA printer, it asks what kind of material do you want to use, and I've got gray resin in there, version 4, and you can set your resolution. 0.1 being 100 microns, 0.05 being 50 microns, and that's pretty standard for most of the times I do printing is 50 microns. So I'm just going to click apply, and we'll navigate over to open our file from last week. So I'm going to go to my ZBrush streaming folder, which is on my desktop. Here's the STL file. Let's bring that in. While that's loading, I'm checking comments on Facebook. Kevin Pasco, what's up, man? Got Aita Abhishek Gupta. Awesome. Igor Nezevich, good to see you, man. Been a while. And Mateus Zadikov. Hey, Mateus. I'm looking forward to watching your 3D printing class, too. It's looking dope. Okay, cool. So Facebook comments are live. Twitch comments are live. Okay, Matthew on Twitch has a question about 3D printing. Would like to sell some of my models on the internet for 3D printing. What do I need to do to make them 3D printable? I made them in ZBrush. So I go over this pretty much every stream. So just tune in and watch how I go through the preparation process. If you want to see how I went through the process of preparing this one that we're printing now, you can just check out the last week's stream or the stream before. Primarily, that just means that your ZBrush model, you've got to make sure it's Dynamesh. It's all one solid watertight mesh. Sometimes you hollow it out. You also have to decimate it down to a resolution that you can actually send it to the printer, not like 8 to 20 million polys, maybe like a million or less. So those are all things I talk about. All right, Raython Studio is saying, I think your Form 2 has lost its Wi-Fi. Yeah, that's true. I haven't set it up since I came to the new place. I just moved here, I don't know, maybe 2 months ago, and so the house is still a total mess. Um, but the good thing about Form 2 and the N2 Plus is that you don't need Wi-Fi for either. You can print just by connecting them via USB or via a cord. So I'll probably set up the Wi-Fi shortly. Anyways, here's the I don't even know what to call him, Dwarven Cleric that I created using Hero Forge, and this is ready for print in SLA, or we're preparing to print this in SLA. You see it came in at 23 millimeters tall, and what I want to do is decide my scale and decide my orientation and supports before I print it. So the first thing to do is to just move it around, and you can see I can do that here. I can rotate it here, but I want to decide the scale. So I'm going to click on this top left button where it says size, and I'm going to adjust the size. Now you can they're all locked together, so you can just do it manually, bit by bit, or you can set a height specific to your dimensions. Say if we wanted to press 6 inches tall, that is 152.4 millimeters. So I'll just type 152.4, and that is 6 inches, but that's 6 inches on its longest axis, which is there. I need it to be here, 152.4. There you go. So now this is a 6-inch tall print. You notice that when I make it too large for the print volume, it's going to turn red and let me know, hey, this is not going to print. All right, so this is a very large print, and it is not hollowed. So ideally, I'd hollow the print out for SLA 3D printing, but this is something I'm just going to show you how to set up. I'm not going to print this right now. So if I were to print this character, I wouldn't print it just like this, because for a few different reasons. The main reason is that there's a lot of overhang. So when I slice from the side, you can see what happens. So most of it builds from this bottom area upward, kind of like a pyramid, which is good. That means that every area below it is supported well, but that's not the case for all of this. Let me scroll down to here. All right, let me show you this area. So you can see that there's this whole area that's coming out of the side. It's like the sleeve for this character that has no support, that is creating a very wide ledge. So this is a very wide and very thin ledge. And this is not going to fly. Like this kind of thing needs supports. Same thing down here. If I scroll down to the end of this book, you can see that there's like an island forming on its own. A few different islands. And these islands, when they're not connected to the print itself, these are going to cause a failure. And so if you don't give a proper support for these islands, they're going to fail, and then everything above it is going to start failing and cascading. So this whole book probably wouldn't come out if I didn't support it properly. So that's the first thing. The other thing is sometimes you can get a better angle just by rotating the character a little bit. And now you'll have better growth from a small point to a large point, because that's what it's all about with SLA printing, is trying to find one of the best orientations so you can support and add the minimal amount of supports so that this character is secured, and then everything grows pretty organically from that point. So already by doing that, I've solved a couple of problems. This ledge now is going to come in much more supported, so I don't need to add supports there anymore. So that's one less thing. And I just need to add supports to this book area. The good thing about Preform is that it auto supports for us as well. So all I need to do is find a good angle. I can come to this button down here, Supports, and I can increase the point size if I want. That's the size of the support that connects to the printer. I think 0.7, 0.8 should be fine with this. And then I can increase the density. That's how many supports are created. With this, I can go with the default settings around 1 and 0.7 and click Generate. Now, SLA printing is printing upside down. So whatever you see on the build platform, it's actually printing the opposite of that, and then it's printing upwards, rising from the resin while the UV laser hits the resin down here, attaches whatever the laser hits to the build tray that's dipping down and coming up. Yeah, agreed. Without hollowing, this is going to use way too much material, and it's going to be way too expensive. You can see that's 407 milliliters down at the bottom. Actually, you guys can't see that on your screen. My screen resolution needs to be pulled up. I'll show you guys in a second once this is done generating support. All right, few people are asking, printing upside down, is it possible? Yes, obviously you can print this character in any orientation. What do you think of Preform's auto orientation? Depends. I don't rely on it. If you press this button at the top left, I believe this magic wand, you can basically have Preform, whatever model you bring in from ZBrush, you can have Preform auto-oriented, auto-add supports, and auto-send it to the printer. And it's smart, but it's not as smart as experience and knowing how to set it up. So I'll show you the difference shortly. So I'm just waiting for it to generate the supports. It's a large, heavy print, so it's going to take some time. David Giroud on Facebook is saying classic fail. Yeah, for the FDM printing I did earlier. SLA prints fail too. And so you have to, with 3D printing, it's a constant battle with failure. I don't want to give you guys any illusions that we live in Star Trek times yet where you can just have a replicator and then just press the button and it's going to create the thing for you. It doesn't exist yet. There's always failures with 3D printing. In fact, I had a failure with this SLA printer just yesterday. Turn on some lights. And I can show you the failure I just had on the SLA printer while we're waiting for these supports to generate. Okay. With SLA 3D printing, you've often, it's more work for cleanup because you're dealing with materials and chemicals, so it's better to wear gloves, pop it open, slide the build tray out, and I could show you something that happened over here. So you can see here's a failure that I got just yesterday, printing a couple of pieces that were very well supported, but they just sheared and dropped. This one just dropped right off, and this one, though it stayed attached, also sheared. So what this was supposed to be was kind of like lips, but it just turned into mush. And this is not usable anymore, so this is just trash. So you get failures in 3D printing all the time. It's par for the course. So these I'm just going to toss. I'm just going to use this little pry handle to get under there and pop it off. You can just drop it. All right, that is all off the build tray now. Let's do a little scraping. And I'm going to wipe this and put it back in. Now, failures are caused for a few different reasons with SLA 3D printing. One is maybe you didn't add enough supports. The other is that maybe your supports weren't strong enough, like you went too small with the point size, which I've been known to do before, because the larger the point size, the more damage to the print. So sometimes I try to get away with smaller supports. So that's one issue. Another issue is maybe you didn't orient it perfectly or check to see if there were any islands. The other issue is your tray is simply dead. So the bottom of the tray, after a while of the laser hitting it, just burns out, and it has a lot of bubbles, and it just is useless after a while. You could also have old resin. So it could be part of the material that causes the failure. All right, so that is cleaned up and put back up in there. However, there's another check you have to do when there's a failure, which is to just slide this slider at the bottom of the printer and check where that failure was on the resin tray itself. For that, I tend to use your standard spatula to just check if there's any hard elements remaining in the tray, and then just remove them. So I already found them. They're right here. I'm going to lift them off, up off my print tray. Here we go. We got that first one. Let's see if there's another one. Right here, there's another one. Grab that. So if there's any hard pieces in your build tray that are relatively large in size, your tray won't be able to come all the way down. It'll just get blocked by the ones that are there. And it knows not to fight, not to resist against the heavy stuff that's causing it to stop going down. All right, there's that. The good thing with the Form 2 is that it's usually got this very handy-dandy wiper which wipes away any debris that falls all over to the edge, so your print can continue. It's not immediately a failure. But it's good to find and sift out these little pieces so you can have better prints. You can even use a comb for this. I found that to be useful at times. But it's just a matter of finding any detritus in your tray. With this print in particular, I feel it was likely just that the tray is older, but I don't think so. That's what shearing usually indicates, that you have a bad tray. But this is a relatively new tray, and I don't see any bubbles at the bottom. Get that bit. All right. So I can show you guys some of the debris that came out of there. There's a little top of the lips that just sheared right off. And it's not that thick, but that's thick enough to cause a problem. And a couple more pieces just like that. I'm going to toss these. And failures don't stress me out anymore. They used to. But now I'm just older and wiser. I can see what causes the failures, and I know how to fix it the next time. So I just kind of assume sometimes that, yeah, it might fail. It sucks when you're on a client job that needs to get done. That's why you gotta have a healthy time amount when you say you can do a 3D print commission. You can't do it overnight. All right, here we go. So this is done adding the supports, and you can see it's added a lot of supports. The printer's auto supports likes to think of any area that could possibly need supports and just add it. Especially, and this depends on density. So the density was set to 1, so that's why it's taught, hey, let's just add extra supports. One cool thing with Formlabs' latest update to preform is that whenever possible, and it has to build supports on the mesh itself, it tries to avoid using the old way, which was it used to have a tripod, 3 different support nubs on the mesh at the bottom, and then rising up to the support at the top. But now it often tries to just put 1 at the bottom, or maybe 2 at the bottom like you see there. You can also go in and edit these supports. So in the support menu, you can click on Edit. And all those little blue points that you see, that's where it's adding a support. You can also add larger points, and you can see that's now a point with a much larger point size, and that's with a much smaller point size. So depending on the scale you're printing, you can adjust the point size you want. Now, it's better to have some very large ones on your print as well, because the Form 2 printer, as it moves up and down on the print bed, sometimes it can drop your print. And so when you add these kind of very large ones, they act as anchors, securing your print to the build platform, build tray. No, build platform. And so these anchors now are going to be larger, heavier supports. And if I feel I don't need supports in any specific area, I can just go down. I just click on them, and it gets rid of those support, and it just doesn't need them anymore. Wherever it thinks it needs it, it'll just start making your mesh red, and it'll let you know, hey, please add a support here. You can click Apply Support Edits, and it'll do that. All right, Rethon Studios is saying, what's the material cost with supports? So I'm going to calculate that very shortly, as soon as this is done applying the support edits. Kevin Plasko is saying, have you ever replaced your Form 2 build plate? By build plate, I think you mean the actual platform that's moving up and down, the build plate. Yes and no, because this is the Form 2. When I had a Form 1, I had replaced it because I had a lot of issues with the Form 1 when I first got it. With the Form 2, it's been kind of a workhorse for me. I've done 30 prints in 30 days that were all successful multiple times. Complex prints too, large prints, small prints, prints for jewelry, prints in multiple materials, for wax in clear resin. So I've had a lot of success printing on the Form 2. My failure rate, I'd say it's maybe like 10%, 15%, but it's always there. It's always likely, especially with the first prototype. All right, here we go. So this is done. Preparing. All right, I'm going to raise the screen up a little bit so you guys can see the bottom. And I'll show you how to calculate cost for a print. All right, so do you guys see this at the bottom of the tray now? I'll actually raise it up so everyone can see it. It says 460.85 milliliters. Now, Form 2, the material itself comes in like this. It comes in like a liter bottle that you can slide into the printer. You see one that's out of the plastic. Looks like this. You pop open the top, you remove this tab at the bottom, and then you just slide it in behind the printer. And this is about a liter of material. This is tough resin. Now, the resins and calculating the material cost is very simple. It's about $150 for a liter of resin. At least this is Formlabs proprietary resins. So $150 now divided by milliliters is about 1,000. So it's 0.15 cents. So it's 15 cents per milliliter to print. So if I do 0.15 multiplied by 460.85, that's including with supports, that comes out to a $70 print. So for a 6-inch print, this is not very tall. This is a 6-inch tall print with all the materials used. Just on the material used, this would be about $70, or almost half the resin available in my print, in my bottle. So this is a very, very expensive print. This is unnecessarily expensive. This is grossly expensive. What you could do is simply hollow it out, and then your material costs would drop drastically. Like I could reduce this material usage for the same size print by hollowing from 460 down to maybe 150 or 200 milliliters tops by just hollowing, because it wouldn't need to fill in everything. So you see this whole area being filled in? It doesn't need to use that much material. It would just hollow all of that out and it would just be gaping. There's nothing inside there except some support material on the inside. And so that's one way you can definitely reduce your material usage a lot. Sean Lake is saying $150 per liter. That correct? Yeah, we can check it out, dude. All right, so let's do Form 2 materials. All right, so here's gray resin. Actually, the prices are listed all right there. Go back. All right, so Form 2 standard materials, the gray resin, the clear resin, the white resin, $150 each. Some of the more specific types, like castable wax resin used for jewelry and dentistry, oftentimes $299 for the liter. So it's even more expensive. Now, this is because Formlabs makes their money kind of like HP or I'm thinking of any printer brand, like 2D printer brand makes their money, is by selling ink, by selling their material. Now, you can use just standard resins with your Form 2 machines or any SLA printers. You don't need to use their materials. However, the printers are formulated to use their materials, so it knows the exact temperature to use their materials. Now, there's a lot of different materials, like resins. You can buy a liter of resin for something like 50 bucks or for 30 bucks even. Let me see if I can find some of those. Okay. Well, I can't find them right now, but I know that you can get resins for 3D printing that are very, very cheap. So there's a couple of issues with getting third-party resins. With the Form 2 in particular, it doesn't let you print more than 150 milliliters at a time with third-party resin. The reason they state is that they don't know the temperature that it's curing, and they don't want to do the auto refill with third-party resins because they don't know if it'll overspill and cause a problem. Now, that's a very valid concern, but I think more than likely they just want to incentivize you to use their material so that they can make more money. All right, people are asking, can you adjust the infill or hollow it in preform? No, that would be an amazing feature to have, to be able to hollow directly in preform. But I've shown you guys a few times how to hollow things out in ZBrush and how to hollow them out in another software like Mesh Mixer. So I can show you guys how to hollow it out in ZBrush. We can switch gears now and start doing some ZBrushing again. So that's basically how I'd prepare this for 3D printing. I'd likely hollow it out and prepare that. So I'll show you that workflow, and then we'll get started with some new project for today. Indie Respawn is saying, in future stream, would you be willing to cover how to make different articulated joints in ZBrush? Yeah, I wouldn't mind. Stay tuned. I might do that a couple weeks from now. All right, please hollow it out. How you doing that? Sure, I'll show you guys how to hollow in ZBrush. All right, so I'm just going to go to my Z plugin 3D Print Hub, and I'm going to import that STL file that we had saved. In last week's stream, I had this Dwarf Warlock STL file, so I'll open that up. And Rethon Studios is saying, any problems curing hollow prints? Yes, there can be, because you're only curing from the outside. So the inside doesn't necessarily get cured, but that doesn't necessarily matter. It doesn't matter if the inside is cured or not, depending on the thickness. You don't want to hollow very, very thin. I'll tell you right now, I know it's tempting to save a lot of material, but you want to hollow as conservatively as possible. When you hollow really thin, there can be all sorts of things. There can be ruptures, there can be not enough support, there can be just drop-ins where it just kind of caves into your print. There can be issues with once the print comes out fine, but then you're curing it in isopropyl. Some certain areas are too thin and it starts just creating a hole and then just pops. Or isopropyl can get stuck inside and then just pool in a certain area and then eat through the print. You can have it sit outside and in the sun it'll start warping because it's too thin. So be conservative with your hollowing. Alright, so this is how I go about hollowing a print. You open up your model in ZBrush. Now this is already a decimated model. Ideally you'd probably do this with a Dynamesh model, but I'm just going to start. What you're going to do is go to your brushes and go to your IMM primitives. Maybe navigate over to a cylinder. And if you draw out a cylinder normally, you can see it draws out just like that. You can adjust the depth in the brush palette and it'll go deeper into your print. That's under brush depth. You can adjust this. I like to bury these a bit halfway through so that they're halfway on the inside, halfway on the outside. Now if you simply Dynamesh it just like this, it'll add it on. So the cylinder will be added on to your print. But I don't want to do that. I want to hold Alt as I draw this cylinder out. And you can see it's completely different. It drops a negative of that cylinder. Basically the normal's flip version of that cylinder. And now when I go to Geometry, Dynamesh, I don't want to just click Dynamesh. I want to click Create Shell. So when you add your inverted cylinder and then you go to Create Shell, you can set the thickness. So like I said, I'm pretty conservative when it comes to hollowing thickness. I'll set it to 10. And the resolution obviously needs to be something that's high enough to get the resolution you need. So let's try 100 and let's click Create Shell. See what happens. Mateus is asking, do I hollow the pieces in ZBrush or in Mesh Mixer? I'd love to have the following system of Mesh Mixer and ZBrush. Yeah, that's true. I really like the hollowing system in Mesh Mixer. If you guys have a second, I can show you that here too, to compare and contrast with ZBrush. Alright, what's happening? Looks like nothing's happening here. Looks like didn't do anything when I click Create Shell. And that could be because my model's decimated and not already Dynamesh. So you know what? First thing I'm going to do is just Dynamesh it at the resolution. Let's do 200. So it's not perfect. I'm just showing you how to hollow. So at 200 resolution, let's do 300. It gives me enough resolution so that it's not super janky. I'll come in here, draw it out, and then now I'll click Create Shell. And now it should work. See, there you go. It works perfectly. And it created a shell for us. I can go to my select rectangle and look at what it did. Turn on my double-sided. And here's the shell. So the hollow that it created, it removed that. And it's all on the inside. And it's pretty thick. So at 10 thickness, that's a very thick hollow. Honestly, at 6-inch print, I could probably go at half of that. I like being conservative, but not that conservative here. Let's go thickness of 5. And that's plenty. That's still very thick. That's about, I'd say, 3 millimeters or 4 of thickness, which is plenty. But you can see there's a lot of jankiness on the inside. So the one thing I like to do is select the inside, Control-Shift-Click on it so it's only what you see. And then I just smooth the heck out of it. Because you don't need unnecessarily detail on the inside of your mesh. Everywhere that it has detail, like this kind of stair-stepping, Preform would try to add a support, which would mean the whole inside would be covered in supports, which would mean there's no point in hollowing. So you want to go in after you create the shell and smooth all of it out. There's also a lot of areas that will do this thing where it'll just create a very, very thin negative, and it's going to want to try to preserve that. You don't need that, so you just, I toss it. Same thing here with the hands. You don't need very, very thin areas, so I just toss them. The way I do that is by going to my Select Lasso tool and then just deleting everything or leaving everything that I want deleted on. And I'll show you what that does. I'm going to delete some of these little top points as well. It's kind of a fine art just knowing how to hide the parts you don't want to delete and then inverting that selection. All right, here we go. All right, so if I want to delete all of these parts, I'm just going to invert my selection by Control-Shift dropping. And now all of this stuff is hidden while this stuff is visible. So I can just go down and say delete hidden. That's under Geometry, Modify Topology, Delete Hidden. And it tossed everything that I had previously on. And I can Dynamesh again, just a regular Dynamesh. And what that does is it fills in this stuff. So let's actually do a new grouping. I'll mask this area along the edge. I will click Group by Masked. I'll hide that and I'll click Auto Groups. And so that way it's created an inside group for me. And then I can just see the inside group. Now you can see those areas that I deleted were just filled in. And ZBrush does a good job of just filling those in. And this is my hollowing workflow. I like to smooth out all of the detail on the inside whenever possible. And now this is looking good. Whoop. See just the half. There we go. So now our hollow is looking pretty clean. You don't need to hollow everything, like this horn has no negative in there. But this is pretty much a perfectly hollowed print ready for printing. But now you'd probably want to decimate it again. So I'd go into Z plugin, Decimation Master, pre-process current. And once that processed, I'd decimate it. Sean is saying I'm fast. Yeah, I'm used to this. I've done this a million times. People are asking about 3D printing services, talking about Shapeways, talking about Ownage. Ownage is still in business. I believe they just have such a backlog of orders they don't really run their public-facing website a lot. All right, here we go. That's pre-processed. I'm going to click Decimate again. And now this is ready to send back to the printer. So this is 55,000 polys. Super decimated down. I just kind of did it for the demo. It's a bit janky. I wouldn't do this, print this. But if you get enough resolution in there, you can go up to 1 million polys in preform without any pain. And now this is hollowed, so it'll be just much less resin used. We can try that out in the background while we work on something else. I'll export to STL again. Hollow demo. So this print we already went over was 460 milliliters at 6 inches. I'm going to toss it. I'll open up the one that we just hollowed. Make sure it's at the same height or scale. I believe that was 156.4. There we go. That's 6 inches tall. Oriented the same way. I'll add generate supports. Joanne's saying, do I have a URL or website for them? No, I unfortunately don't. I had Ownage's contact email when I first started trying to do these testing and printing, and I did get some quotes from them. So I could email them and then find out if they're still around. Yeah, I'll email them and find out and let you guys know next week. Rethan is saying, wouldn't you get a pocket in the staff? No, you wouldn't get a pocket. It would just print it completely solid. The PLA prints need to be hollowed like that or sliced. PLA prints don't need to be hollowed. When you send it to the printer's automatic process for, ensuring the mesh is properly filled on the outside automatically can hollow the inside. It creates kind of like a crisscross effect. Now, double check with your printer settings to make sure it's doing that, otherwise it'll use a lot of material. A lot of times you do hollow for PLA or an FDM printing. It's just a different process. You don't need to send it a ZBrush kind of hollowed mesh. All right, Serious Carrier is saying, Serious Caller, what is the reason to tilt the model when slicing? Now, I just am in a habit of tilting the model when printing for SLA in general, because you want to print, it's hanging upside down, remember. It's not printing like this, it's printing like this. And so you want to have enough supports on it so that it prints well. Also, you want to make sure it's printing from a small point up to a big point. And so when you're thinking like that, then it's better to just tilt your model oftentimes. When you print it just like that, it's got a lot more surface area, then it doesn't necessarily have the best orientation. I don't know if that was a good explanation. Basically, you orient it in order to have better supports, building from small to large. All right, this is almost done generating supports. In the meanwhile, I can open up Mesh Mixer and show you how to go about hollowing there. This is a good, nice, long demo for a Monday morning, talking about printer failures, talking about hollowing, the reality of 3D printing. All right, Mesh Mixer is here. I'm going to click Import and open up that model. I'm going to go to ZBrush Streaming and navigate over to my not hollowed model. We'll open that up. This might take a while because it's a heavy file. We'll go back to Preform. Here we go. Preform has generated supports now, and this is now down to 229.3. So already we've lowered our cost from $69 to $34. So just by hollowing conservatively, I've reduced the cost of this print by half. It's still a $35 print. I could probably lower it down even more, but with SLA printing in fine quality using a Formlabs machine, this is kind of what you got to assume, that your print is going to cost anywhere from $20 to $60 if you print the full size. But still, not bad. You could, and if I print the same exact print in FDM, it's probably going to cost me $5. So that's the thing you've got to juxtapose. Do you want the quality? Do you want the resolution? Or do you want to just prototype? Sometimes FDM is way better for that kind of thing. All right, here we go. This is the model brought into Mesh Mixer. It's probably massive because I exported this out at 23-inch scale. Oh, no, here we go. It's brought it in millimeters. That's fine. I'll do that again. I'll make it 154 millimeters. Accept. Wait, double check that. The highest, that has to be 154 millimeters. There we go. Accept. All right, so this is about 6 inches tall now, and when we're getting ready to print this and we want to hollow this out, first thing you'll notice there's a lot of little red dots, and so this is the kind of thing when you import into Preform, it says repair, and it repairs those because those are very flattened. When I did a clip in ZBrush and flattened certain areas, those are the areas that were flattened and have overlapping geometry with nothing there. So we want to get rid of those. And in Mesh Mixer, you can go to Analysis, Inspector, and Auto Repair. And it should get rid of those for you. There we go. Those are gone. Done. Now I can go to Edit. And Mesh Mixer is a free software, by the way. Feel free to go to meshmixer.com, download it, and try it out. All right, so now I'm going to go to Edit, and I want to hollow it. So I'm going to click on Hollow. And I'm just going to think about it for a second. This is a pretty heavy mesh. Rethon Studio is saying Form 2 all the way for miniatures. Definitely. Much cleaner. All right, Sean is asking, have you used or considered Octoprint along with the mobile app for your phone to monitor and control your prints from afar? Now, the good thing is Formlabs Preform software, and Raise 3D both offer online monitoring options using their own sites, so I don't need to use Octoprint. I still don't like, printing in ABS on this thing just because I feel like I want to check up on it more. All right, here we go. So if you look now, Mesh Mixer has hollowed this out, and on the inside you can see it's created this really janky mesh for the inside of the hollow. You can also set, and this is what I like about Mesh Mixer, you can be a lot more precise than ZBrush. You can tell it exactly the offset distance. So this is 2 millimeters border thickness along the edge, and you can set that to more or less precisely. 2 millimeters is fine. I may actually lower the mesh density is fine too, but I don't want it to be so accurate. So I might lower the accuracy, and this will just smooth it out a bit more. I might increase the density, and let's try to update the hollow and see what happens. All right, here we go. So that reduced it a lot. So that don't want to reduce the accuracy that much. I'll try updating the hollow again. All right, here we go. So now that is a much more accurate hollowing with a bit of smoothing. So it's basically finding the balance in Mesh Mixer, setting the exact distance you want, the exact accuracy, the exact density, and just updating the hollow. See you later, Sean. Catch you next time. All right, cool. Here we go. So now that looks pretty good, but now we need to connect the outside mesh with the inside mesh. So we're going to create a hole, and we can set the radius. So I can set the radius pretty high here, 3 millimeters, and I can make a couple of them. So let's make 2 holes per hollow, generate holes, and here we go. Those are the holes it's generated for us. We can set them both back here if we want, and click generate holes or accept. And it's going to connect the inside and outside at those points. Let's wait for it. There we go. Done, and it's generated those holes for us. And this is now a mesh that's hollowed and ready for printing. Again, same way as hollowing in ZBrush. I just showed you how to hollow in Mesh Mixer. It's pretty simple. You go to Edit, Make Hollow, set the settings, create the holes, click Accept. That's it. And now you can go to File, Export, and save this as an STL, and just start your print. So for FDM, I might actually fill in said hollowing, but I'm not doing that right now. That just generate complex on the inside of the hollowed material. But I'm not doing that right now. That's plenty. It's 9 o'clock, so let's get started on today's project. So in any case, check in next week. I should have Amazon deliver the PLA filament probably tomorrow. So I'll start this print. So by next week, Monday, when you guys come in, you'll see the print in 16 inches. Hopefully it went well, and I'll have that for you. What I want to do right now is a little bit of ZBrushing on my IP fungosaurs on a project I've been working on. I've been working on the app right now, and you can see here's the little DNA that I've animated in Maya. Deoxyribonucleic acid. I'm going to do a little render of this later. Save this out. DNA. And I will open a scene for a project I started working on last week, or 2 weeks ago with you guys on my stream. Believe it's saved in. Here we go. All right. So here's my fungosaur character, Braco. It's a Brachiosaurus mixed with a witch's hat mushroom. And so that's why you can tell it's got that weird funky head. Still trying to go for a cute, appealing character. but this is very low res game resolution mesh. I believe this is not like 4,000 or 5,000 tries. We can check that out. Heads up display, poly count. Here we go. So that's 6,000 tries in total for this mesh. I believe that's including the eyes. Yeah, no. Including the eyes, it's a total of a little more than 7,000 tries, which is still plenty for a mobile game kind of character that's going to be animated. So I showed you guys in my ZBrush stream a couple weeks back how I sculpted this character and how I posed it for retopology, and then how I retopologized this. I showed a little bit of retopologizing in ZBrush. That's how I generated a bunch of this, was the auto retopology using the retopo in ZBrush. And then I brought it into Maya to do some fine retopology by hand, just because that's my preferred workflow. And now this is fully retopologized game resolution mesh. I also UV'd it. So if I go to my UV editor, you can see how I've laid out the UVs. There's the body, and there's the head, all flattened out. So now this is ready to start painting. So that's what I wanted to do. I wanted to start painting this and generating my maps, my high res to low res maps. And I can show you how to generate a normal map today. I can show you hopefully how to create a finished game character right now, really quickly. So you can see where the seams are at, right there, the white outline. And I might open up the mouth a little bit as well as I create these maps. So let's export this out and take it back to ZBrush. I have a 3D print of this character. I can show you. Let me save this out. Not as an FBX, I'll probably just save it as an OBJ this time. And let's open it up in ZBrush. Okay. There we go. Open that up. All right, now that's a thing that worries me. It says it's not all quads and tries. Now that's going to give us a problem. So let's make sure that this is all quads and tries. I'll run a mesh cleanup. I believe that's under here. Where is mesh cleanup? Blanking right now. Mesh cleanup. There we go. And I'm going to make sure that I select any faces with more than 4 sides, and I can clean them up automatically. So let's clean up. Let's zoom in on those. Okay, so this is a couple of points in the feet that were not quads. Looks like only in 1 foot. How strange. Yeah, that's fine with me. Strange, though, that it generated so many extra edges. Double checking that to make sure that's all clean and I don't have any unnecessary edges. Okay, that's looking all right. Cool. So what I'm going to do now is export this out again. Delete by type history. It should be faster this time. File, export, selection, game res, overwrite, sure. ZBrush, delete this one. And I will import it in again. No warning that time, so that's good. Alright, so here's my model brought into ZBrush. Now this is my low-res game model. So I'm going to duplicate it, and I'm going to, I just like to do that right away as soon as I bring in any mesh. I'll divide it up a bunch of times. About 12 million polys. That should be solid for painting it up. I can also then check my UV map while I'm at it. So I'll go to Texture Map, Create New from UV Check. I want to make sure I'm maintaining my UVs, so that's good. I've got my UVs, I've got my model in here, and this one's ready to paint it up. Turn the texture off. I'll apply a skin shade material. Fill object. Alright, so the first thing I want to do is fill in a base color for this, and I can show you what this character is. Alright, cool. Make this screen a bit larger. Alright, so the journey of this character that I'm showing you is that I did this first 3D print, which is the 3D print that was painted by my guy Elvin, which was the prototype. So this shows how the model was intended to look, and that's the color reference for me now. This is the factory character. I mean, this is the toy from the factory. So I'm pretty pleased with how it came out, considering this is a mass manufactured toy now. And I should be getting these shipped to me right now. So it should be coming in via boat next month. How cool is that? And this is the plastic as it comes out of the injection molded tool for mass manufacturing. So the same character, we use the 3D print as the prototype to create the tool with multiples at the same time, and then here's the plastic parts. Now these are a slightly flexible plastic, industry standard, and this is the mass manufacturing that I'm doing right now for my Fungusaurus toy brand. Now the other thing I'm doing is, 3D printing the ideas to reality. 3D printing is what allowed me to make a toy line. It allowed me to prototype. It allowed me to understand and communicate with toy manufacturers, find a factory, and place an order, get them the files they needed, and do a QC, quality control, with them to have my mass-produced toys. It would be pretty hard if I had no knowledge of 3D printing, so it was really useful to have that background. Now what I'm doing over here is I'm preparing the game asset, because at the same time as I launch the toys this November, I also want to launch a mobile game which will allow you to bring these characters to life in augmented reality. It's kind of like a Pokemon Go thing, but beyond that. I want there to be a lot more mini games. I want this to be more fun, kind of like Tamagotchis used to be, like a virtual pet. So for the game character, I need to repaint it. I need to come up with the textures. So first thing I'll do is I'll import in or load in my model so I can have easy color picking and reference in the scene. Go to my Braco character. Should be good. Let's check it out. Okay, draw that out here. Alright, so here's the model that I printed. Slightly different looking, a bit derpier. In the game model, I'm adding more eyelids so that I can actually emote with the character a bit better. Alright, so here's the model that was printed. And what I'm going to do now is go up in here. Now this one doesn't even have the colored version. Let's open up this one. One of these has the colored painted version. Here we go. Here's the colored painted version in ZBrush. Now you can see it's super simple paint job, so we shouldn't have a problem doing this in the next 15 minutes or so. I'm going to make sure this is filled with the right material. You can tell a few different things I did for 3D printing. The first prototype I did was very thin, so I thickened it up. And this is what 3D printing is really good for. It's understanding engineering physical things so that you can see, okay, this area is too thin, there's not enough balance, need proper support, things like that. All right, I'm going to fill this with my skin shader material, just with M, so I can have a similar base to draw upon. And I will go to my, delete this one. I will append this onto here. You can see they're slightly different axes. We'll rotate this around. And I will move it. It looks like he's trying to mount himself. Okay, here we go. So I'll just keep this in my scene as I paint, and then I'll have an exact reference of what the paint color should look like, feel like. We'll go over to here. I'm going to select this character's paint, and let's use this yellow as the base color. That yellow right there. Go to MRGB with my standard brush on. With RGB intensity set to 100, I'll just fill the object. So now I've got my base color just by picking the color off of here. I'm just dragging this color picker from there to here, and I can get the colors that I need. Let's just paint the red stuff first, because that's easier. This is a witch's hat mushroom. It has this nice yellowish red coloring. Make sure my Z add is off when I paint. And I can just paint directly with standard brush like this to be smooth, or I can add, a few different alphas. You can also lower the intensity. Kind of paint it out. So first step is to just kind of get a base idea of the colors. So I'm not even going to have anything else. Looks like I've got the whole back being a little bit red. So let's do that. Let's redden out the back a bit. As if it's getting a lot of sun. I love painting in ZBrush too. Anyone been trying Substance Painter? I'm hearing a lot of good things about that, but I haven't jumped in myself. Well, I've tried it, but I didn't really get very far. Hard when you're a professional artist to keep track with all the latest software and stay on top of it. But it's kind of our responsibility to do as professionals. Stay on top of all the latest and greatest. You can do so many things in ZBrush and Maya already, in Modo, that I don't necessarily want to learn new stuff all the time. I want to make stuff. Okay. I'm going to paint those feet red as well. I don't mind if there's a bit of unevenness because this is an organic character, so that doesn't throw me off at all. Do want to make sure that I get the feet from all sides. Red at the bottom. Cool. All right, so there's the kind of very, very, very first pass base painting. Let's also add these yellows. Looks like I've got a darker gold tint going on for some of these areas. Add that in. And I think this is kind of just an occlusion pass that I kind of do. Kind of, sort of. It's not really true occlusion. Just kind of painting it in. more of the sun baking thing than occlusion, really. Occlusion is a shadow effect that you try to recreate. All right, so now one thing I'm being confronted with right away is that I can't paint the inside of this character's mouth. So that's going to cause trouble for me later. I want to be able to paint it. I also want to be able to generate normal maps and such without any detail just getting crunched. And if you have a model intersecting or really filled in like that, it has a hard time generating good normal and occlusion maps. So I'm going to, open up the mouth right now. Brave Hun's asking, I'm not afraid of giving the factory. I assume he's talking about my files and then they're going to steal my ideas. Yeah, honestly, it's always a fear with mass manufacturing, especially if you go to, I don't want to say China specifically, but just in general, outside of your own country to mass manufacture. But you got to sometimes just pull the trigger. You got to make it happen, And so I just committed. I found a factory that's reputable, that comes recommended from a few different friends. So that's what matters, is you got to just start. All right, so what I'm going to do right now is I'll go all the way to the lowest resolution on this character mesh, on subdivision level 1, and I'm going to open up this mount. See a few different ways of doing that. I can try to just select the bottom, and here we go. That's a pretty good mask that was generated by dragging my transpose line. I can soften it by just tapping, make it a bit larger, and I can also hard mask areas I don't want affected, and then I can try rotating, see what happens. All right, so it's grabbed the top jaw, but it's also bottom jaw, but it's also grabbed a bit of the top jaw, which is not ideal. Still, need to open the mouth, so I'm gonna open it. Tap once there. Okay, now let's select the upward. And now move that up a bit. I've already got my excuse me. I've already got my game mesh that I'm going to be using in Maya. So I'm not using this as my game mesh. I am using this as just my baking and painting mesh. Now you can tell with this character I didn't bother making a really deep pocket on the inside of the mount. I might adjust that, but that's not in this one. This file is solely for painting the, you know what, I don't know, I might actually use it because this is the right resolution, it's got the right UV maps on. I may rig it with the mouth open. So good to just take a second to think about these things. I move that schnoz a bit, mouth open and down a bit. Taking a second to just clean up this model. Transposing doesn't always work perfectly. Oftentimes you'll need to just touch it up by hand and then move it around. All right, I'm going to play some music as I do this now. Some Take It Easy lounge jazz. And we'll spend the last half of this just figuring out the better paint and getting this exported and back into Maya as my game mesh. Plenty of resolution in here. Created extra edge loops. I'm going to create the space I need, the pocket. Always hard to sculpt on topology that is like game res topology. But luckily this one is not a lot of tries. And I might actually add a tongue for this character as well. That might be fun. Not gonna bother with teeth. He's a, what do you call it? He's a veggie-eating dinosaur. Vegisaur. May need a bit more resolution in here, so I may update this mesh back in Maya. I'm just gonna clean it up enough that I can paint right now. All right. Yeah, I probably will add another edge loop, kind of take that down into the neck a bit. But we'll do that later. I can update that once it's back in here. Thanks for joining me for the stream, everyone. Good to have some company as I work away on a Monday morning. What time is it where everyone is at? In LA, it's Monday morning. It is now 9:28 a.m. Where are you guys tuning in from? Okay, that's looking good. Like I said, I'll probably add a tongue in here, so I'm not too worried about the bottom of the mouth. Got to be careful when you're using the clay brush. It'll go right over through to the backside. Turn on back face masking when you do your clay sculpting. All right, neat. Mouth open. I'm going to save this file before I forget to. Sabatot saying it's 18:30 in Hungary. You gonna military time me, Matt? I think 18:30 is 6:30 p.m. if I know my military time correct. Spain, 6:30 there too. Portugal, nice. 10 p.m. on Monday in India. Yeah, it's nighttime in India. Thinking about going back to India for a visit shortly. We'll see if I can make that happen. Okay, cool. File saved. Let's get on with the painting. So now I'm ready to start adding more different color textures. So instead of painting with just my standard brush, I'll switch to a color spray, and then I'll also switch to an alpha like alpha 07 to add some variation. Want to paint at the highest resolution. Okay. Let's start by dropping some on here. And you can see it's very subtle. I'm not trying to overdo it with the painting. What this does is it just adds variation. And variation is important. Adds a bit of breakup so your character doesn't feel completely solid. This feels more like organic skin. And you build in layers. Alright, so that was kind of an orange base layer that I added onto everything. Now I'm going to add a bit of red. This will be a bit more visible for you guys. Still very subtle, you can tell. I want to have a, you know, break up the transition here between the red and the yellowish orange. Let's paint the inside of the mouth now. I guess I want to do a reddish in there as well, but maybe a lighter reddish, maybe pinkish. Yeah, and for this I don't really need it to be color spray. I can go back to my freehand and turn off my alpha. This is kind of a smooth inside of the mouth. And got to make sure my back face masking is on, otherwise it's going to paint right through. Back face masking, for those of you that don't know, I have it at the bottom of my UI, but for you guys it's under masking, I believe. So you go under brush, auto masking, back face mask, and you can turn that off or on. In this case I want it on. There we go. Getting a lot of nice pink in there. Pretty little pink. Alright, so now when you go deeper into the mouth, you want to make it a darker color as you go in, just to add a bit more contrast. Don't want to forget about the top of the mouth. The seams right here along the side. Make that even a bit darker. Perfect. A little bit coming through here on the outside. Just going with the small brush and fix that up. Cool. You can smooth out that area. And I'll fix that in post. All right, so that's looking good. Off to a right start. The eyes now, kind of want them to be slightly pinker than this color. A bit brighter. Because it'll draw attention to the face, you know? If you have these kind of details and highlights, and in general, when you're making characters, you want a bit more detail in their faces so that it'll bring people's attentions up to the face. Human eyes are naturally drawn to detail. Let's go darken up these nostrils. All right. Also brighten the top of them. Now I like to paint in a little bit of the specularity of these characters into my diffuse map. Just because, I mean, it's not necessarily a good habit. I'm just telling you what my style is, because I know what I want this to look like. Cool. Just hitting all the highlight points. Some more than others. Don't want to lose that nice red up top. I forgot to do the little transition dots at the bottom here. So let's do those again. Whoa. Symmetry doesn't always work perfectly because this is an asymmetrical model. I like asymmetrical models. Like same thing as the head, just a bit more detail to work with, you know? Cool. Take a look from the bottom. Going with that yellow. Let's go in and add some occlusion shadows. I'm going to be careful when we do this. And let's make the bottom of these feet red as well. Don't need the spray for that again. Making sure my back face masking is on. Okay, almost there. Now you can see here that I had quite a bit of detail in the previous feet that I've lost when I did the low-res game mesh. So I want to do it again. Got a few more questions. Dave Birdwug is asking, which city in India? I mean, if I come at the end of this year, beginning of next year, I'd want to go to Mumbai, Delhi, and I don't know, maybe South. I've never been to Goa. That might be fun. All right, Max Tail is asking, how big did my 3D print go? Max, you missed the first part of the presentation where I talked about how I ordered the wrong kind of filament. I ordered ABS rather than PLA filament. So now I've ordered the right filament, and I'm going to print it later today. So it should be, when you check in next week on Monday, you should see the print. Cool. Got fans in Delhi. I haven't been to Delhi in almost 10 years. Okay. All right, so what I want to do now is sculpt in a bit more of this detail like I had previously. And this is more for the normal map than for color, but still, good to get it in there. Now this is something I'll probably have to do just manually. I'm just doing it inflate. I'm going to inflate these edges. And hopefully they'll read a bit better in the normal map than they do here. And I can reinforce these with a bit of texturing. I like the funness of making creatures. And I like animated style. I like stylized characters. Any character that can actually make a connection with people. And I gave this character 6 legs, so I got to do it 6 times. I'm going to come in and pay a bit closer attention to the feet. What's everyone's favorite thing to sculpt around here? I mean, it's a ZBrush stream, so I'm imagining a lot of you want to be character artists. But ZBrush is pretty solid for environment stuff too, and mech stuff, and all sorts of stuff these days. There we go. Adding some bulbousness to the feet. I'll probably come and hit it with the damn standard after I'm done inflating. Push some of that detail back. Clip the bottom as well. Looks like I thought I had symmetry off. Looks like I did. I'm gonna make sure that this is a little bit unique from the other side. Almost done, last one. This is the downside of starting with a 3D printed model, like a toy model first, in pose, in prototype, is that when you get around to making the animated mesh, or animatable mesh, you have to resculpt a bunch of stuff. Alright, I'm going to make sure my perspective mode is off, and then I'm going to clip the bottom. So, undo this once it's done. Oh no! Wait for it to respond. Hopefully it won't crash. Woo! That was close. Turn off perspective mode. Save right now. Sabatot saying it'd be good to see some hard surface tutorials that are up to date. Agreed. It's hard to stay up to date with ZBrush stuff because it changes so quickly. It seems like every, year they launch a new ZBrush. I'm wondering what they're going to launch this year in November for their ZBrush Summit. Last year, I believe they just launched a new ZBrush 4R8. All right. So hard to clip these feet exactly. Clip the bottom of those. Took a while to clip, but there we go. That bottom is now clipped up. Okay, so now we can go in with some damp standard. Switch to my DS brush. Come in and just add in a bit of detail there. Mostly the top of the crease, not really interested in the bottom. Be a challenge to see for the normal map to see how much of the detail it can actually get into the mesh. If I was doing displacement or if I was doing a mesh for animation, I'd probably do it differently. But since this is a mesh for a mobile game, I don't want to use too much resolution. So on the one side with 3D printing, once you have your prototype done and you print it, if that's your final product, you're done. If a toy is your final product, you're done. But if you're trying to go for an animation or game res mesh, you got to start over. You got to make the model again. Make it twice. That's why it's better to not sculpt at pose. Not sculpt posed. It's better to sculpt your character sometimes at T-pose or rest or relaxed pose, rigging pose, so to speak. But it's hard when you're coming up with a concept, especially a creature character concept, to come up with that character's appeal, find that character's voice and strength at a T-pose. You don't really feel it. So it's a necessary step to go through this. I feel it's a very necessary step. Want to make sure I'm not getting any weird inflations like this. Go down to my resolution, smooth it out. Up at my resolution, smooth it out again. There we go. Good. Back to damn standard. I like these strange feet. This character is really shuffling around, but I have a feeling with these kind of feet, it can probably even stick to surfaces, you know? All right, it's getting a bit hard to paint on the inside legs, so I'm going to switch to my select lasso and hide a bunch of this character, so I can see the legs that I'm working on. Also press solo, so I'm not looking at anything I don't need to. Strange. Cool. Frame in on that. And now I can finish the legs. ZBrush people are very good at development, indeed. That's the good thing about ZBrush, is that it feels more like sculpting, and like it feels like an actual, you know, artist tool, as opposed to Maya, which definitely feels like a production tool. You know what I mean? So a lot of this character's feet, detail, are at the feet and at the head. So it's going to make you focus on this character's movement and their face. Simple. You'll notice that when I'm smoothing, it's not smoothing my texture because I've got mRGB turned off for my smooth. Go down in resolution once, just smooth out the tops of all these creases. That looks plenty good. Let's go ahead then and start adding some dark shadows into here. Back to my standard material. I'm going to pick up darker black, blackish red. Start to fill those in. Kind of like it's got webbed fingers. Color really changes and adds a lot of shape. I'm hoping to get away with that. A lot more shape added from the color than with the normal map. almost 10 a.m. I'm going to be signing off soon. But let's try to generate some maps from this to see a first pass of what this looks like in Maya. I can keep refining and figuring out the texture later. Asymmetry is the key to creating an interesting character. So plenty of asymmetry in these feet. All right. Hidden all these with smooth. And let's also make this transition a bit cleaner. Go back to color spray. Fine line. I think I'm going to come hit it all with a little bit of darker red overall. Break it up a little bit. And then let's hit the top as well with this. Break up, pass. Cool. Let's also hit sides with a bit of this orange and yellow again. Do a smoother transition. Whew. Shaking on all about. All right. So if I turn solo off, you'll notice that my original had a bit of lightness that I need to bring back, as well as some striations. So I want to add a bit of those over here. Let's pick a brighter yellow color. I like that this color palette is very simple and refined for me. Spectre Dave saying baller got a Form 2 back there. I have earned this printer quite a lot, and I've made it work for me. Printing, I don't know, regularly for almost 2 years. Alright, so this is how I go about doing these striations. Alpha 60, just freehand. And just changing up the direction a little bit. Up and down. Changing up the scale of my brush. Changing up the thickness. It's got to make it feel organic. And I don't want to do crisscrossing. It's kind of like he's got a little haircut. I can also switch the color back to red and then have some red stripes come down. So it ties it all together. Got to make sure I'm coming down at the same angle as these yellow stripes. Look at it from the front, make sure we have enough detail along the front of the character. Because imagine we'll be seeing its face a lot. This little bit of color will help a lot with making this character feel more organic. Because I do want it to feel like an actual mushroom dinosaur. Got to change up the scale of the brush often. Don't want to get trapped into repetition. Alright, that's plenty good looking for a first pass. Let's check it out back in Maya. Alright, so here's what we're going to do. In order to see this exported out, I'm going to go to my texture map and new from Polypaint. Now I believe I had 10 million polys, so I'm going to go the highest resolution, 12 million, and then make sure to generate from the highest resolution. There we go. There's our first color pass. I'll clone that texture. I will flip it vertically and I will export it. Let's do a PNG. Let's call it diffuse 1. Back in Maya, I'm going to assign a new material. Let's make it a blend material so there's a bit of specularity to it. And navigate over to my material attributes and bring in that color file. Navigate over to my folder. Okay. And here we go. Let's up the diffuse amount a bit so we can really feel the brightness that we're going for. You can press 3 to see the smoothed out version of the character. So good, we've got a good amount of breakup on there. We've got the stripes showing through, adding a little bit of detail, but it's mostly base color. That's good. Texture is reading well on the mouth. The eyes being highlighted brings your attention over to them as well. So that's looking good. Let's try generating a normal map and see what it does with the feet. Now I've tried generating a normal map with ZBrush. It doesn't give me the best results, and I'll show you what I mean. So in ZBrush, you can go down to low-res subdivision level 1. Go to your normal map. Make sure you have smooth UV on. Likely. I don't know. I might turn it off for now. Tangent normal map, create. Blands is asking which is more satisfying, creating or 3D printing the result. That's a good question, man. The cool thing about 3D printing is that I can get from nothing, something in my head, to a physical character, like a toy or a physical thing, within a day or two, you know, even less. This probably takes about 2 hours to print. The satisfying thing about animation and game characters is that though the process is a bit more involved and complicated, you can move that creature and you can animate that creature and you can create films with it. And so that's a completely different kind of satisfaction. All right, here's the normal map generated out of ZBrush, and we'll compare and contrast this. I'll stay on for another 5 minutes or so. Let's do normals 1, and I'll show you a couple of different approaches. So that's one way of doing a normal map. I'll show you my other way of doing a normal map, which is we want to export out the low res. So let's say game res, let's say low res 1. We'll go up to the high res and we'll duplicate it because I don't want to export out 12.8 million polys. I'll duplicate it. I will delete the low res, delete lower, and I will decimate this. So pre-process and decimate so that I maintain the detail, but then I'm going to get rid of a lot of the topology. I don't need 12 million polys for a high res. I'm going to show you the X-normal workflow for creating normal maps. It's very satisfying for me, and that feeling of 3D printing something and seeing it in hand, it still hasn't gone away. It's always an excitement to see something that was in my head that didn't exist, that now does exist. So it's kind of a power trip. But making game assets and animation assets, besides being my bread and butter, working as a VFX artist in Los Angeles, it's also very satisfying to animate and bring life to a character, you know, like by movement. All right, pre-process is taking a minute because it's higher res. In the meanwhile, I can open up X-normal and we can load in our low res. Here's X-normal, very simple, easy, understandable interface. I'm going to clear all the previous meshes and let's bring in our low definition mesh. You know, I think I can just drag and drop it, but I'll just navigate over to it right now. Here's the low res, bring that in. Baking options, I want to generate a normal map. Let's maybe generate an ambient occlusion. Cavity map, why not? Height map, that'll just basically be a flat diffuse for now. Curvature, that might be useful if we're taking it to substance. I don't think we are. Yeah, that should be plenty. And a base texture, so there's no height map. Resolution, 2048 by 2048 should be solid. Call it Braco 1. Save them all as PNGs. Added the underscore at the end. Now we just need to plug in the high-res mesh. And what X-normal is going to do is take the high-res mesh, project it onto the low-res mesh to generate all these maps for us. So I'm going to wait for the high-res to get done. Stick around with you guys for a little bit longer. While we're waiting for this to load, I'll point you guys to pixelogic.com ZBrushLIVE presenters, and I believe Shane Olson, who's an excellent character artist, has a presentation later today. 27th, yeah, later today at 11 o'clock. So in 45 minutes or so, you can see Shane Olson do his magic with some stylized characters as well. Looks like he's been working on this blue man, and so you can see him continue that. Highly recommend Shane's classes. Taken some of them myself. And if you want to follow my IP and the work I'm doing, you can check out the latest on fungusaurs.com. And that's the IP that I'm building for my own game and toy launch at the end of November. Successfully Kickstarter funded last November, so by this November I want to deliver all the toys to everyone. Also on Instagram as Fungusaurs, so you can stay tuned with the latest on the toys and game that I'm building. I go into a lot of the manufacturing photos as well as just fun photos, merchandising out in the wild. Here's the finished toy box. Hoping to have that in stores and shelves by the end of the year. So that's Instagram Fungusaurs. And if you want to follow me, you can go to Instagram, Aiman Akhtar 3D. And I post all sorts of stuff in there. Family stuff, images, projects that I've worked on. So you can follow me on Instagram there. Alright, here you go. It is done now with the process it was doing, pre-processing. So now I'm going to decimate down to 20%. This is still 2.5 million polys, which is way too much for the simplicity of this model. So I'll decimate it down to 5%, 640,000, that's plenty. And I think I can still see most of the detail. Yep, more than enough. I will export this out as my high res. High res. And let's drag and drop that into XNormal as well. Here's the high res. Alright, and then let's start this bake. We should be able to get a normal map, an ambient, and a base texture and a cavity from this. Click Generate Maps. I'm going to take a second to process through and find everything. Here's the normal map. Let's also open up the normal map that was generated out of ZBrush. I don't know if I saved it out, so let's compare. Alright, I will export that normal map out. Alright, game res normals, it's already there. So this is the normals generated out of ZBrush. And these are the ones coming out of XNormal, I believe. I may be inverting those. Alright, so here's the normals I believe coming out of ZBrush, these guys, and these are the ones coming out of XNormal. So let's compare. Alright, so if these are the XNormal ones and these are the ZBrush ones, you can see ZBrush ones have a lot of janky artifacts. They've got, anywhere there's any hint of interpenetration, it's going to do that. It's going to kind of create like weird specular effects on the normal maps. And I've had issues too where it adds a lot of faceting that's not necessary. Versus the XNormal one, it looks a lot cleaner. Let's see if this is the case. I may be inverting like I said. These look like they might be the ones generated out of ZBrush, yeah. So this is the one generated out of ZBrush. And it's got a lot of weird faceting. You see that like weird lines that are coming up? It's trying to show me the low-res topology in the normal map, which is not ideal. I want it to be smoother. So I'll have to fix some of the artifacts in this XNormal map, any kind of interpenetration that's happening. But let's see what this generates once we drop it in Maya. Go back to the material attributes. Under bump mapping, select a file, set it to tangent space, and navigate over to our file. We'll use the normals generated out of, there we go, X normal. So if we take a look, not bad, pretty good start. Some things I have to fix, but at least that gives us a hint of the detail we're looking for. And if I don't want to see the normal map, I can just focus on the diffuse, make that look perfect as I want, and then get on with the animation. So by next week, I should have this character all rigged up and start animating him too for my app. I'll add some of this occlusion and cavity map stuff on top of my texture in Photoshop as well in order to make it really sing once that's all done. But in any case, that's today's stream session. Thank you so much for joining me, everyone. Hope you learned something or enjoyed my process. Thanks, all. I'll say thanks for joining me, all. Joanne's asking, we'll be able to order direct from Fungusaurs. That's the plan. Hopefully, once I have the website updated, you can order directly from me as well. Thanks to everyone for joining me on Twitch. Thanks to everyone joining me on Facebook. And make sure to stick around for Shane's presentation in about 45 minutes.